For section 4.3, we're going to cover the slope of a line, kind of how to look at a line and tell whether it's positive or a negative slope. How to figure out the difference between a zero slope and no slope, because they're not the same thing. What I start off with here is the definition of a slope of a line, which is a ratio. Ratio is just another way to state that it's a fraction, or it can be a fraction, a rational number, that describes a line's vertical change, it's y, to its horizontal change, it's x, so it's change of x. And what we're going to do is, you can go ahead and jot that down. For the types of slope, what you want to do is, I'm just going to show you some general pictures here, but when you do this, look at it from left to right. So a positive slope is going to go in that progression right there. It's going to look like that. So, they can be really slight. It can be like that. One way just think of it like going up a hill, all right? And then a negative slope is going to look like this. And the thing I was going to say was that when I was learning this, my teacher always said, put your pencil on your line, and make sure your eraser, make sure this eraser part is in quadrant 2 or in quadrant 3, and just look at what your pencil's doing. Is your pencil pointing up, or is it pointing down? All right, but that's only true as long as you put your eraser in one of the 2 left quadrants. And then it's really easy, because sometimes people misinterpret them. Like a negative slope, for instance, someone might see this as a line that's going up because they look at it from right to left, and that's the incorrect way we want to kind of observe slope. It's really from left to right. If it has a zero slope, it's perfectly, I'm probably not drawing this perfectly, but it's a perfectly horizontal line. All right, it does not go up or down, it's just flat. And an undefined slope is straight up and down, it's vertical. We'll talk about what makes those zero and undefined as well. Now, the ways to calculate slope, and there's a number of ways you've heard probably: rise over run, vertical change over horizontal change. Some people have seen this, like triangle that represents delta. So sometimes you'll see like delta y over delta x, that equals slope. M is the symbol for slope, by the way, the letter M, lowercase m, italicized. Now, the algebraic way to approach slope is to use a slope formula. Now, the slope formula is going to be y2 minus y1. Now, those are not exponents, those are just ordinal numbers. The second y minus the first y over x2 minus x1. Something like that. So you have, we have an ordered pair, you have your x and y, and then you have another point like that. And really, those are totally interchangeable. Sometimes I'll have people say, is it okay if I just do y2 minus y1, or y1 minus y2? And yeah, that's perfectly fine. You can do that. And then you can do x1 minus x2. So make sure the other one matches up. But it really doesn't matter the way you're doing it. So, it's kind of up to you, as long as you're consistent in the way that you express it. Now, the other thing, too, to remember is that when you're substituting values into your slope formula, you're only substituting the y value. I'm focusing on this one in particular. You're only focusing the y or the x. Notice there's a negative sign, there's a minus sign floating out there before the y and the x, and that's not substituted in or out. That's what's going to happen is when you substitute a value in, you might have 2 negatives next to each other. You might have minus minus, minus a negative, and that makes obviously a plus. And we'll come across that in just a second here. All right, so determine the slope of the line. For this example right here, we want to determine the slope of the line. And, right away, you could probably gather that, hey, James! Okay, moving on to the next page here. We've got 2 examples here where we have the graph. We have 2 points that are indicated on the graph. Okay, now moving on to the next page, we've got to determine the slope of the line given the graph. Now, you'll notice that in this first example here, we've got a positive slope because it's going up, if we look at it from left to right, it's going in an upward progression, and then we have 2 points. All right, and now one way to kind of do this is to draw a triangle. Look at it from a triangle's perspective, connecting those 2 points. And that triangle is going to indicate or show, visualize the horizontal change and the vertical change, the up and down. And the triangle can go either way, go this way as well. It does not matter which way you do it, as long as you identify the up and down as the vertical change and the left to right as the horizontal change. So if we're going to do this, now I'm going to look at this. I see right here that's a change of 2. I'm just counting 2 boxes there, 2 units. And this one's a change of 1, 2, 3, 4, 5, 6. So what we have there is, the vertical change is 2. I'm going to put M for slope. And the horizontal change is 6. And then always simplify. So that reduces to 1/3 or 1 to 3. So the slope is up 1 over 3, and we can verify that just by tracking along. So we can go up 1 and then go over 3. 1, 2, 3. We're back on the line. Up 1 and then go over 3. 1, 2, 3. So it follows that 1 to 3 progression. Up 1, right 3. Up 1, right 3. And it keeps following that forever. I can go up here, up 1, 1, 2, 3, and then we're right there, back on the line. Now for the next one, for number 2, we've got what appears to be a negative slope, because going left to right is going down. And I'm going to go ahead and draw this triangle again, just to indicate the vertical and horizontal change. And then if we look at this one goes up 1, 2, 3, or I should say it goes down. It's going down 4, and then right 1. So if we indicate this as a slope, it's going down 4, right 1. And since it's just 1, we might as well just write it as an integer. So m equals -4. But when it comes to expressing a slope and understanding slope, it's good to think it in ratio terms, as -4 over 1. Now the slope of a horizontal line, let's talk about that first. Slope of a horizontal line, I'm just going to draw like a really rough sketch here. We have a point here and a point there. And let's say this point right here is, let's say this is like -3, 3. And let's say this one right here is 4, 3, something like that. And if we look at this and figure out the slope, we look at the change in y. So you look at the change in y. The change in y is going to be 3 minus 3. And the change in x is going to be -3 minus 4. And if we clean that up a little bit, we get 0 over -7. And then anything 0 divided by anything is going to be 0. So the slope of this is 0. So the slope of a horizontal line is always going to be 0. And then if we look at another graph here, okay, so I've got a vertical line there, just a rough sketch there that I'm drawing. And if we look at this using slope formula, this is x1 right here, this is y1, this is x2, this is y2. Change that, y2. And then we can just put those in. So change in y would be 4 minus -4, 4 minus -4. And then the change of x is going to be 5 minus 5. Now 4 minus -4 means really 4 plus 4. 5 minus 5. Now 4 plus 4 is 8. 5 minus 5 is 0. And one of the things in math, and in general, hopefully you've heard this many, many times before, but you cannot have a 0 in the denominator. Once you have a 0 in the denominator of a fraction or a ratio of anything, fraction-wise, it's going to be undefined. It's impossible. That's an error, on your calculator. If you try to do 8 divided by 0 on your calculator, it doesn't come out to be 0. It'll give you some sort of error message. So this is undefined. For the next page here, we're going to look at just points. We're not even looking at the graph. So we've got an ordered pairs. 5, 8, and we've got 4, 7. So those represent 2 points on the coordinate plane. And let's go ahead and just fill those into the slope formula. Now remember, slope formula, I'm just going to write it down again. Slope formula is y2 minus y1 over x2 minus x1. Change in y on top, change in x on the bottom. I'm going to go ahead and now when we put those in, it doesn't hurt to kind of look at it this way when you're evaluating or substituting values in. And the y, I'm going to go ahead and label this. This is x1 y1, x2, y2. And the y2 is 7, and the y1 is 8, and the x2 is 4, and the x1 is 5. So there's nothing tricky about the way that one's set up. So 7 minus 8 is -1. 4 minus 5 is -1. And then a number over itself, negative divided by negative, is positive. So that equals 1. So what this has, when we describe it, this has a slope of 1. M is symbol for slope, by the way. Moving on to number 4, I'm going to do the same thing. I'm going to just set up parentheses here. So this is our x, this is our y1, x2, y2, and we're going to do this, we're going to do 2 is the y2, and then -5 is and then 2. All right, so I'm going to set this up. I'm going to put 2 right here, and that's our x2, and then our other y1 is 2, and for our change in x, we're going to put 1 here, and we're going to put -5 there. And then 2 minus 2 is 0. 2 minus 2 is 0. And then this is really, right down here, this is really 1 plus 5, which makes 6, right? But that doesn't really matter. What does matter is that we didn't get a 0. But this has a slope of 0. M equals 0 for that one. All right, for number 5. So for number 5, we're going to go ahead and put those values in. So -1 minus 3. And we're going to put 5 minus 2 here. And -1 minus 3 is -4. 5 minus 2 is 3. And there's your slope. And leave it in proper, for sure. Don't change it into a mixed number. So the slope for this one is -4/3. And remember, when it comes to a negative, the negative can be right in the middle. It could be in the denominator as well, or it could be in the numerator. Doesn't matter. But it's still -4/3. Somewhere there's a negative in there. Just one negative, though, not 2. For number 6, we've got 2 minus -5, and then over -7 minus -2. So if we clean this up just a bit, simplify things, we've got 2 plus 5 in the numerator, and we have -7 plus 2 in the denominator. And then 2 plus 5 is 7, and then -7 plus 2 is -5. And there's your slope. That cannot be simplified anymore. So it's just going to be -7/5. And that negative can go anywhere. James, stop yelling. All right, for number 7, we've got everything set up here. So I'm going to put the y's up top. So we got 5 minus -3. There's your y's. And our x's are going to be -1 minus -1. Like we have been doing, I'm just going to simplify things up. Now, if you want to do this all in one step, that's fine. I'm just going to write it out. The top is 5 plus 3, and the bottom is -1 plus 1. 5 plus 3 is 8, and -1 plus 1 is 0. Right there, that's undefined. So the slope is not 0. It's not the same. If you get 0 in the denominator, it does not equal 0. 0 means there's an answer. There's a slope to it. It means it has 0 slope. But undefined slope is different. So for number 8, go ahead and just put these fractions in. We got 3/2 minus 1/2. And in the denominator, we have 4/3 minus 2/3. Well, lucky for us, we have like denominators, so we don't have to find an LCD here. And so 3/2 minus 1/2, 3/2 minus, that is 2/2. And 4/3 minus 2/3, that's 1/3. And what we have right now is a complex fraction, and that's not okay. You don't want to leave things where it's a complex fraction. A complex fraction is where you got a fraction over a fraction. And just think of it like a division problem. We could just do 2 over 2 divided by 1/3, and then just keep change flip. And that comes out to 6 over 2, which reduces to 3. So your slope on this last one is 3. At number 9, we have a point to start with. That's what we're given, and we're given a slope. So what we want to do is let's go with that point. We have 1, -3, so let's go ahead and make a point there. So 1, -3 is right here. That's 1 on the x, -3 on the y, and it's got a slope of 1/2. Now let's talk about what that 1/2 or 1 to 2 means. When you have a slope of 1, 2, that means up 1. You want to go up 1 and then go right 2. Okay? So you want to go up 1, right 2. So we're going to follow that progression. So we're going to go up 1, right there, and then go right 2. 1, 2. And there we are. And I'm going to keep following that. Up 1, right 2. So that's what the line will look like with a slope of 1/2, and it goes through that point 1, -3. Number 10, we have a starting point of 0, 2. 0, 2 is going to be right on the y-axis right here. And then that has a slope of -3. Now, when the slope is -3, just an integer, if you want to think of it in ratio form, just think of it as -3 over 1. So that means down 3, and it means right 1. Now notice on the first one that we did, we went up because it was positive. On this one, it's negative, so we went down. But for both of them, we went right. So that's one way to do it. Sometimes if anyone has trouble kind of understanding how that works, think of it like an elevator. When you get on an elevator, you're either going to go up or down. Then when you get off the elevator, you get right off. I know that's kind of weird, but it works. Get right off. So always go up or down and then go right. Go right off. Think of it like an elevator. Slope is like an elevator in some ways. All right, so we have a down 3. So we're going to go down 3. 1, 2, 3. So we're going to go down 3, and then we're going to go right 1. Right there. And we're going to keep following that progression. 1, 2, 3, and then right 1. And if I want to make more points, I can go up 3, 1, 2, 3. I'm just going to do everything backwards, and then left 1. And that continues our progression. Okay, so that does it for slope.